Restorative versus legal. Crime versus exhaustion of applicable remedy. Rent-seeking versus wealth creating economics. Commercial versus self-governing. Traditional versus modern.
For many years, we have been like blind men touching different parts of an elephant, said Hugh of ideologist Xiao Dong Song. Now, for the first time, we have a sense of the entire elephant, and see what the inner core of Earth really looks like. Using both newly acquired data and legacy data collected around the world, Song and postdoctoral research associate Xin-Lai Sun painstakingly probed the shape of Earth's core. The researchers report their findings in a paper accepted for publication in the journal Earth and Planetary Science Letters. Composed mainly of iron, Earth's core consists of a solid inner core about 2,400 kilometers in diameter and a fluid outer core about 7,000 kilometers in diameter. The inner core plays an important role in the geodynamo that generates Earth's magnetic field. The solid inner core is elastically anisotropic, that is, seismic waves of different speeds along different directions. The anisotropy has been found to change with hemisphere and with radius. In the latest work, Sun and Song describe another anomaly, a global structure, found within the inner core. To constrain the shape of the inner core anisotropy, we needed a uniform distribution of seismic waves traveling in all directions through the core, Sun said. Since the seismic waves we studied were generated by earthquakes, one challenge was acquiring enough seismic waves recorded at enough stations. In their analysis, Sun and Song used a three-dimensional tomography technique to invert the anisotropy of the inner core. They parameterized the anisotropy of the inner core in both radial and longitudinal directions. The researchers then used a three-dimensional ray tracing method to trace and retrace the seismic waves through the inner core iteratively. What they found was a distinct change in the inner core anisotropy, clearly marking the presence of an inner core with a diameter of about 1,180 kilometers, slightly less than half the diameter of the inner core. The layering of the core is interpreted as different texturing, or crystalline phase, of iron in the inner core, the researchers say. Our results suggest the outer inner core is composed of iron crystals of a single phase with different degrees of preferred alignment along Earth's spin axis, Sun said.